Okay, we're going to be talking a bit about the necessity of planning for your lifting and moving activities and the critical part that plays. It follows on from what was said earlier by Marco about the engineering side of things. But before we get into that, a little survey. Okay. I'd like to see you raise your hands if you are or have been actively involved in lifting or moving activities. I'm talking about in the practical sense in the field. I'd like you to keep your hands up. You can take your hands down if you have always had the information that you really should have had before moving people and equipment. We lost a few. Okay, and you can take your hands down if you've always had a great plan before starting work. Okay, I don't think we lost too many there. Keep your hands up if you have ever made the plan up as you went along. We still have a few brave souls who are prepared to admit that, yeah. I would say that we've likely all been guilty at some time or another of proceeding with a lift or a moving activity based on incomplete information or inadequate planning. We've all done it, if we admit to it. Of course, that's, in all honesty, a recipe for disaster. It's an unforgiving discipline. Anything that you lift is always trying to find its way down to the lowest level. And it's going to take advantage of any flaw in your approach. It's there trying to trap you. And like a chain, your plan relies on the integrity of every link in the process, which is the rationale for a methodical approach. If you overlook one aspect of the whole thing, it all comes apart. If you're lucky, nothing too bad happens. Maybe a bit of lost time and money and credibility, but at the very worst, you might do severe harm to people or plant or your reputation or whatever. So it is critical that you get it right and that you take the time to make sure you do. Okay, this is where I'm going to get a little bit of help from the back here. This is based on a real life scenario. It's something that happened to me back in the day.
Hey, Keith, will you send your 90-ton telescopic down to the laydown area? We've just had an unexpected delivery.
My response? We're just getting ready to leave. I think some of the guys might have already left.
It's not going to take very long. It doesn't weigh a lot. We don't want the truck sitting there all weekend.
Okay, let me see if I can find some guys to take the crane down there and we'll get that off the truck for you.
Thanks, but please hurry. It looks like it could storm, and you know how quickly it turns to a mud bath down here.
Sound familiar to anyone? Any flaws in that? Any pitfalls? Are we set up for success? Any alarm bells ringing? Anything I should have done differently? Should I have been so quick to help? You know, we like to please, don't we? Well, I do anyway. Questions that should have been addressed. Can't really do a shout out here, so I'll give you some prompts. Do we have the right people? We've already said, hey, we're all going to go home for the weekend. On that particular job, once they'd got their pay, they were out the door. Did I have the right people? Do we have the right equipment? He asked specifically for the 90-ton crane. Was it the right machine? I don't even know what this piece is. Tell me what you want me to do with it. All of these are questions I should have been asking. Are we being rushed, tempted to cut corners? He says it's going to storm, it's going to turn into a mud bath, I'm being squeezed. Is that going to lead to success? Well, maybe. What about the weather risk? So with hindsight, we came up with a few questions there that really I should have asked. Were those all the questions that I should have asked? Well, there's more. We need a structured approach This is what I'm advocating, a structured approach to ensure that all the essential questions get asked and an optimal solution is arrived at. Back to Marco's point about taking time. You need to find the time to ask these questions. What are the primary requirements for any construction task? People. We talked a bit about training earlier on there. What attributes do you want to see in your people? Well, we talked about skills, knowledgeable, qualified, well-trained, well-organized, knowing what they're expected to do on their game. These are the sort of attributes you're looking for in your people. Good equipment. What attributes should it have? Wish I could do a shout out here, but we don't have the time for that. It should be appropriate to the task. It needs to be well maintained, correctly assembled, and that's an issue in a lot of cases, properly inspected. So we got good people, we got good equipment. Okay, I managed to find a qualified crane operator and a couple of riggers who are qualified to signal. I'll send the crane down. We should have enough rigging there.
Good. I'm leaving. I'll see you on Monday.
Okay, he's off. Good people, good equipment. We're good to go, aren't we? Anything missing? A plan, yeah, we need a plan. Before diving into the task, we need a plan. Okay, what do I need for the plan? Bit of information, yeah. Planning the task, no matter how simple, is a key element for success. So now we've got planning. It needs to be a well-considered plan. Ideally, it's going to be an efficient plan. It should be as simple as possible. Complex solutions are not usually the answer. It shouldn't be pushing the safety boundaries. There should be enough time allocated to do the work safely. And it should preferably as low-risk methodology as you can practically achieve. Understanding, of course, that no activity is risk-free. All three elements are essential for success. So now we're good to go, are we? Who thinks we're good to go? Well, you're hedging your bets there. We got a zone of success in there. We talked about this, or Mike talked about this, and Hendrik talked about this. An often underappreciated but very important influencer of success is a good support system, by which I mean employer support. Safety, training, best practice, people, quality, and technical support. If you don't have good support right from the top, you're ultimately not going to succeed. There has to be that corporate will to do things correctly. So, the best way to consider any load handling task, whether it's lifting, moving, or anything else, is as a logical sequence. And this is really what I'm trying to push, this logical thought process. So let's look at the generic process. And this is somewhat aimed at construction. I don't know how many people here are construction versus any other kind of industry, but it is sort of construction-based. The principles are pretty much the same, whatever. And it's sort of in the nature of a checklist. And not every lifting instance will need every bullet answered, but you may be able to skip through some of the points that are raised. First thing, need to know about the task. What is it? What do you want me to do? Fact gathering. Okay, I hear what you want me to do. Okay, what's this thing look like? You know, what's the environment in which I'm going to do it? These kind of questions. So we want to know about the item, we want to know about the environment, we want to know about the resources we have available to us, what rules apply to doing this work. We want a clear definition of the task, and we need to raise any clarifications with those who have the answers. We need to come up with some ideas. There's usually more than one way to do something. So we need to look at our solutions. We evaluate our options and we select the best option, and we verify that the risk level of that option is acceptable. And if necessary, we go back and circle around and come back at it again. So once we've come up with an optimal solution, we need to document it. Now, if you're doing a low-risk, routine type of activity, you may not need to actually put it down in writing, but it needs to be in some way instituted. So you're going to look at the thing, you're going to say, how critical is this to me? You're going to develop your concept, you're going to do a risk assessment, and if necessary, you're going to document it. So you've been through, we've got all the facts, we've come up with a good idea, we're going to stick it down on paper if we need to do that, and we're going to do a risk assessment. We're going to review it. According to whatever level of risk you've got in this thing, there'll be some prescribed people with the necessary skills and authority to review the proposal. And there's going to be a technical review by your peers, so you shouldn't be reviewing your own work, of course. And then there'll be some kind of an approval process. So that's the sort of thought process that goes into it all. And once you've got an approved plan, you're then good to go. Are you? What do you do once you have an approved plan? You get in a huddle and talk about it, you communicate. It was said earlier on about the necessity of communication. It's vital that you have I mean, how many times do you see a plan that nobody knows about? You've got the paper over here, you've got real life over here. Never the twain shall meet. Actually, I remember a story, I'm getting off track here a bit, but a job in Thailand. We'd done the planning for this lift. Site manager called me on a Monday, he said, hey, I need you to revise that lift plan. I said, fine, what do you need to do? He says, well, they went and dug a trench right where you're going to put the crane, so we're going to have to move the crane. So I got from him where the crane had to go. I said, well, how soon do you need this? When are you going to do it? He said, we did it yesterday. So what do you want to plan for then? We need it for the record. So, communicate the plan. And that's not just the participants, that's also to the people who may be affected by your work, which includes people who are going to be digging trenches. Okay, check. Make sure everything's the way it should be. Is the setup correct? What about the site conditions? What about the weather? Are the controls in place? Do we have time to do this work? Or are we going to be pushed by a visibility window or a wind projector to come along or whatever else? Are we okay to proceed? And then when we start the activity, we need to monitor it to make sure we're still on track. Are the loads okay? Are the clearances okay? What about settlements? Are the load lines plumb? All those kind of things. Make safe. So, and of course, when you finish the job, you're not finished until you've actually made safe. And then at the end of it all, did we learn anything from this activity that we can use to our advantage for the next activity? I don't propose to look at these in more detail. You're presumably going to get a handout, but you can break fact gathering down into these different things, and each one of those has got things that you might want to consider. On the item stuff like, how big is it? Where's the CAG? Where are the lift points? Do I have a good drawing? All that kind of stuff. In the environment, you want to know about undergrounds and all that kind of stuff. You can look at that at your leisure, but you'll get that for a reference. Your ideas, you've got this kind of iterative thing. You come up with some solutions. You evaluate each option. You look at the hazards associated with it, the risk associated with the hazards, the cost, the schedule, all that kind of stuff. And you circle round until you've come up with the best idea. And I would highlight that thing is there's no zero risk activity. You're going to get it down to an optimal level, but you need to be very cognizant of the residual risk and the control measures that you need to put into your plan to manage the residual risk. Document, you're going to look at how critical is it? And your employer or your client will probably have some kind of a process or procedure that says, if it falls within these boundaries, then this guy has to approve it. If it falls within these boundaries, this guy has to be in charge. You're going to refine your plan. Your risk assessment tends to be an iterative thing. You do it once, and you do it again until you get it down to the level. and there becomes a final risk assessment. Now, if you're doing something pretty routine or whatever, your risk assessment might simply be, looking at it from a quick cast around. Hey, do I see any power lines? Hey, do I see any undergrounds? But if you're working in a refinery situation where there's all sorts of stuff going on, a more formal process may well be required. And whatever. Review and approval. Okay, taking that logical process, how might I have applied that to my South American project? And what might have changed if I had have applied that process? Let's wind the clock back. Okay, I've managed to find a qualified crane operator and a couple of riggers who are qualified to signal. I can send the 90-ton crane down, but before I do, I have a couple of questions.
Okay, go ahead.
First, what is this piece? What do you want me to do with it?
It's a cylindrical storage tank, weighs about 30 tons, sitting on the road on a Goldhofer trailer alongside the laydown area. I want you to locate it in the laydown area, close to the transport, uplift the tank from the trailer, slew 180 degrees, and lower it onto the blocking. It's got 4 lift points on the top, suitable for 12-ton shackles.
Okay, sounds possible. The ground is good down there. There's no power lines or undergrounds, and there'll be nothing else going on. I assume we have the room there for the crane and the load.
Yes, there's plenty of room.
How large is the tank?
It's 9 meters in diameter, 6 meters high, with a conical roof.
9 meters? What's it made of?
Fiberglass.
Ah, not sure we'll get that with the 90-tonner. Let me check. Quick sketch. Looking on there, we need to be out at about 9 meters. We need about 22.8 meters of boom. Bit of room for the rigging. So kind of looked to me as if I needed to be out at about 9 meters radius. So it looks like the nearest I can get's 9 meters radius. I'm good for 28.1 tons. The tank weighs 30 tons, so with the rigging, hook, etc., I'm out of capacity.
So you're telling me you can't do it?
Okay, here comes the squeeze, Not with the 90-tonner, and I don't have any other options till Monday. I'll see what other options we have between now and then, and I'll draw up a plan of action, and I'll get back to you on Monday with an answer. Looking at this, do you see any temptations on there? Yeah, see if I can get this thing to work. Don't think I have a strong enough thumb for this thing. Oh, there we are. There's my 28.1, 22.8 meters of boom, 9 meters of radius. Any temptations with that boom length? Can I get that in maybe? Can I get 8 meters? 32 tons. Tank weighs 30. What do you reckon? Hook block, a bit of rigging. Ton for the hook block maybe, a little bit of rigging, half a ton maybe, well less than that. I'm going to get up there in the capacity if I do that. Monday morning. I've had a look at that lift. We're going to walk the crawler crane down there. Thanks. Sorry, Murray. Any thoughts on that? Okay. Richard, words in your mouth here, Richard. I reckon they should have just driven the trailer into the laydown area just off the road. You could have brought some steel stools round with a forklift and used the trailer hydraulics to offload. But if you had to use a crane, I reckon the 90-ton crane could have worked. How so? To which my colleague would have said, the tank's circular, you could have tucked it in between the outriggers to get closer. I think you could have got 8 meters radius without any problem, and that would have given you 32 tons. With the hook block weighing a ton and the rigging about 100 kilograms, that would have been enough capacity. Would you have been content to lift at 31.1 tons? Depends how confident you are in the weights that you have. You would want to make very sure that that 30-ton tank was really 30 tons. But if you had a degree of confidence, it charts. That's a judgment call to make there. So here we are, 8 meters. Well, that's the original 9-meter plan, I should say. But you see, we could have probably tucked that thing in between the outriggers. Here's the 8-meter solution. So with a bit of thought, we could have actually made that work if we were sure of the 30 tons. Okay, who thinks we should have gone with my colleague's thought? Looks like most of you want to use the crawler or the trailer. Again, with a trailer, I mean, there's more than one way to skin a cat. You know, trailer might have been the way to do it, just drive it down there and use the stools. If we had stools available in the forklift. Who thinks we should have used the 90-tonner? Not many takers there. I don't see any, in fact. Okay, the lessons you take from all this. Take the time to fully understand the problem. Probe and research and take a logical, sequential approach. Don't be squeezed into making snap judgments. Take the time to thoroughly check out the possibilities. And your first idea isn't necessarily your best idea. You might need to circle through a few ideas. Don't be pressurized into knee-jerk solutions or cutting corners. Get a second set of eyes on your plan. There's always someone there who works alongside of you that can take a quick look and give you a second opinion. And involve the participants in planning. This is something we're seeing more and more, where they're throwing this on the engineers and they're taking away from the participants. If you do that, you take responsibility away, you take ownership away. Planning any kind of lifting activity should be a joint venture between those who are engineering it and those who are actually going to be executing it. And we start to see this diversion. We don't want that. Get the participants involved in the planning activity. They come up with ideas often that you might never have thought of. If your plan is complex, it probably isn't the best solution. Your plan document should be as comprehensive as it needs to be to communicate the intent. Who are we communicating to? We're communicating to the field, but who else are we communicating to? We're communicating to the people who have to approve the plan, who are carrying the risk. The site manager, the project engineer, those kind of people. They're not looking for the same things as the field people. They're looking for things like, what % of capacity are you using? Are you intending to put your crane right where my foundation is going to be? Do I know of some undergrounds that you don't know about? So you're not just communicating to the participants, you're communicating to those who are going to review and approve the plan on the management side. So your plan needs to be as comprehensive as it needs to be, but it doesn't want to have a whole lot of fluff in it. So what you don't want to see in there is a whole lot of corporate guff risk assessments which just tell you to wear your PPE and stuff like that. Doesn't belong in a lift plan. So that's my final point, I guess. Target your risk assessments, keep your plan to the point, and keep the stuff like wear your PPE for a kind of blanket risk assessment for all of your lifting activities. Keep your lift plan specific to the lift plan.